AWS recommends a smaller RDS instance, and the CPU chart looks low. Should you click Modify? Not yet. An RDS database can run out of memory, connections, I/O, or network capacity, even when CPU looks safe. Before downsizing, check these 7 metric groups. Start with at least one complete business cycle, 14 or 32 days, and longer when seasonality matters. In CloudWatch, review both average and maximum values. Include month-end processing, reports, backups, and batch jobs. There is no universal safe percentage. Compare your workload peaks against the limits of the proposed instance and storage configuration. First, project CPU onto the smaller class. If 4 vCPUs reach 35%, simplified CPU demand is 4 multiplied by 35%, or 1.4 vCPUs. On a 2 vCPU instance, that becomes 70%. Check sustained usage and short spikes. For burstable T-classes, also check CPU credit balance. Next, check DB load in CloudWatch Database Insights. DB load measures active sessions running on CPU or waiting for resources. Break it down by CPU, I/O, locks, and SQL statements. If the CPU portion repeatedly reaches the available -v CPU line, downsizing increases risk. If waits dominate, investigate that bottleneck first. Check Freeable memory and swap usage together. Databases intentionally use memory for caching, so low Freeable memory alone does not prove that the instance is undersized. The warning signal is declining available memory combined with persistent or growing swap activity. A smaller instance gives the database less room for its buffer cache, queries, and connections. Check the peak database connections value against the engine's effective connection limit. A smaller class can provide less memory and connection headroom. Look for connection storms during deployments, traffic peaks, and application failures, not only the daily average. Also confirm that connection pooling is working correctly. Review read IOPS, write IOPS, and disk queue depth. Compare peak demand with both the provisioned storage capability and the EBS limits of the proposed DB class. If queue depth rises during workload peaks, I/O requests are already waiting. A smaller instance could make the problem worse. Next, check read and write throughput together with read and write latency. When available, also review EBS I/O and byte balance. Draining burst credits, increasing latency, or saturated throughput can reveal a storage bottleneck that an average CPU graph completely misses. Finally, check network receive throughput and network transmit throughput. These metrics include application, monitoring, and replication traffic. Because a smaller DB class may provide less network bandwidth, include peak traffic, replica activity, and failover requirements in your comparison. Downsize only when CPU has headroom, DB load is controlled, swap is healthy, connections have room, and I/O and network demand remain within the target limits. Test first, confirm your rollback plan, use a maintenance window, and monitor the same metrics after the change. That is how you right-size RDS without turning savings into an outage. Subscribe for more practical AWS FinOps lessons from Usage.ai.